So remember we talked about hybrid text yesterday, and that was one that has two distinctive parts to it. A narrative part that sounds like a story, and an expository part that sounds like they're teaching you a ton of information, right? And they're giving you facts. We're going to look at how a video or TED Talk or speech could kind of do the same thing. So maybe not reading a book, but looking at something online where you're watching a video to learn something, how it might go back and forth between giving you information and telling it like a story, okay? So our goal today, Alejandro, can you read our goal today?
To work with
hybrid
text and become a
experienced
experience at thinking about
complex
text and the way they are made.
Yep. So we're going to think about how this TED Talk was made and think about what they did to kind of separate those two parts between the story, the narrative part, and the expository. All right. So I'm going to open that link. Everyone, please make sure you're muted because we're going to watch and listen to this video. Okay, I'm going to hit play and I'm going to ask thumbs up to make sure people can hear it, okay? So let me see here. I'm going to put on share computer sound.
Are the ones that create the most uncertainty. They're the ones that question the things we think to be true.
Can you hear that?
Yeah.
Okay, we're going to go back to the beginning.
So this game is very simple. All you have to do is read what you see, right? So I'm going to count you so we don't all do it together, okay? 1, 2, 3. Amazing. What about this one? 1, 2, 3. All right. 1, 2, 3. If you were Portuguese, right? How about this one? 1, 2, 3. What are you reading? There are no words there. I said read what you're seeing, right? It literally says what are reading, right? That's what you should have said, right? Why is this? It's because perception is grounded in our experience, right? The brain takes meaningless information and makes meaning out of it, which means we never see what's there. We never see information. We only ever see what was useful to see in the past, right? Which means when it comes to perception, we're all like this frog. Right? It's getting information, it's generating behavior that's useful.
You're going to jump scare one.
And sometimes when things don't go our way, we get a little bit annoyed, right? But we're talking about perception here, right? And perception underpins everything we think, we know, we believe, our hopes, our dreams, the clothes we wear, falling in love. Everything begins with perception. Now, if perception is grounded in our history, it means we're only ever responding according to what we've done before. But that creates a tremendous problem, because how can we ever see differently? Now, I want to tell you a story about seeing differently. And all new perceptions begin in the same way. They begin with a question. The problem with questions is they create uncertainty. Now, uncertainty is a very bad thing. It's evolutionary a bad thing. If you're not sure that's a predator, it's too late, okay? Even seasickness is a consequence of uncertainty, right? If you go down below in a boat, your inner ears are telling you you're moving. Your eyes, because it's moving in register with the boat, say you're standing still. Your brain cannot deal with the uncertainty of that information, and it gets ill. The question why is one of the most dangerous things you can do, because it takes you into uncertainty. And yet, the irony is, the only way we can ever do anything new is to step into that space. So how can we ever do anything new? Well, fortunately, evolution has given us an answer, right? And it enables us to address even the most difficult of questions. The best questions are the ones that create the most uncertainty. They're the ones that question the things we think to be true already. Right? It's easy to ask questions about how did life begin or what extends beyond the universe, but to question what you think to be true already is really stepping into that space. So what is evolution's answer to the problem of uncertainty? It's play. Now, play is not simply a process. Experts in play will tell you that actually it's a way of being. Play is one of the only human endeavors where uncertainty is actually celebrated. Uncertainty is what makes play fun. Right? It's adaptable to change, right? It opens possibility, and it's cooperative. It's actually how we do our social bonding, and it's intrinsically motivated. What that means is that we play to play. Play is its own reward. Now, if you look at these 5 ways of being, these are the exact same ways of being you need in order to be a good scientist. Science is not defined by the method section of a paper. It's actually a way of being, which is here. And this is true for any.
Okay, so I just stop it really quickly. Right now, is the part he's talking about and going into these details, is it narrative telling a story, or is it expository giving us facts and information? Give me a thumbs up if you think it's a narrative, and give me like a fake high five if you think it's expository. Ready? 1, 2, 3, go. I see Marvin doing something. I don't see anybody else. Thank you, Corbin. Yeah, high five. It's expository, right? He's teaching us facts and giving us information. He's talking about what it's like to be a scientist and what things you need to think about, all right? Now we're going to try to pay attention because as he keeps going, there's going to be some parts where he shifts to narrative and tells a story, and we're going to try to catch some of those. I'm going to let it keep playing, okay?
Anything that is creative. So if you add rules to play, you have a game. That's actually what an experiment is. So armed with these 2 ideas, that science is a way of being and experiments are play, we asked, can anyone become a scientist? And who better to ask than 25 8 to 10-year-old children, because they're experts in play. So I took my B Arena down to a small school in Devon, and the aim of this was to not just get the kids to see science differently, but through the process of science, to see themselves differently, right? The first step was to ask a question. Now, I should say that we didn't get funding for this study because the scientists said small children could make a useful contribution to science, and the teacher said kids couldn't do it. So we did it anyway, right? Of course. So here are some of the questions. I put them in small print so you wouldn't bother reading it. Point is that 5 of the questions that the kids came up with were actually the basis of science publication the last 5 to 15 years. Right? So they were asking questions that were significant to expert scientists. Now here, I want to share the stage with someone quite special, right? She was one of the young people who was involved in this study, and she's now one of the youngest published scientists in the world, right? She will now, once she comes onto stage, will be the youngest person to ever speak at TED, right? Now science and asking questions about courage. Now she is the personification of courage because she's going to stand up here and talk to you all. So Amy, would you please come up? So Amy's going to help me tell the story of what we call the Black Walton Bees project. And first she's going to tell you the question that they came up with. So go ahead, Amy.
Thank you, Bo. We thought that it was easy to see the link between humans and apes in the way that we think, because we look alike. But we wondered if there's a possible link with other animals. It'd be amazing if humans and bees thought similar, since they seem so different from us. So we asked if humans and bees might solve complex problems in the same way. Really, we want to know if bees can also adapt themselves to new situations using previously learned rules and conditions. So, what if bees can think like us? Well, it'd be amazing since we're talking about an insect with only 1 million brain cells. But actually it makes a lot of sense they should, because bees, like us, can recognize a good flower regardless of the time of day, the light, the weather, or from any angle it approaches it from.
So the next step was to design an experiment, which is a game. So the kids went off and they designed this experiment. And so game. And so, Amy, can you tell us what the game was and the puzzle that you set the bees?
The puzzle we came up with was
Okay, so now we see him telling about what they did in class. So now I want you to talk to me. All right, show me. Thumbs up if he's doing it, if it's narrative now and they're telling a story. High five if it's expository and they're just teaching facts. Ready? 1, 2, 3, go. Thank you, John. Nope, no one's doing anything. Kayla, thank you. Thank you, Corbin. Thank you, Marvin. Yeah, right. Now they're telling a story. They're telling about what they did to actually test this. All right. They're not giving facts. They're actually talking about what they did, the process. All right. I'm going to hit play and we're going to keep watching. We got about halfway through. We got about half left.
was an if-then rule. We asked the bees to learn not just to go to a certain colour, but to a certain coloured flower, only when it's in a certain pattern. They were only rewarded if they went to the yellow flowers, if the yellow flowers were surrounded by the blue, or if the blue flowers were surrounded by the yellow. Now, there's a number of different rules the bees can learn to solve this puzzle. The interesting question is, which? What was really exciting about this project was we and Bo had no idea whether it was work. It was completely new and no one had done it before, including adults.
Including the teachers. And that was really hard for the teachers. It's easy for a scientist to go in and not have a clue what he's doing, because that's what we do in the lab. But for a teacher not to know what's going to happen at the end of the day. So much of the credit goes to Dave Strudwick, who is the collaborator on this project. Okay? So I'm not going to go through the whole details of the study, because actually you can read about it. But the next step is observation. So here are some of the students doing the observations. They're recording the data of where the bees fly.
She's finishing off that.
So what we're going to do...
Starting.
Is she still going up here?
Yeah.
So you keep track, please.
Wait, can you help me?
Can you help me, Henry? What good scientist says that, right?
And two up there. And two.
Right, so we've got our observations, we've got our data. They do the simple mathematics, averaging, et cetera, et cetera. And now we want to share. That's the next step. So we're going to write this up and try to submit this for publication, right? So we have to write it up. So we go, of course, to the pub, all right? The one on the left is mine, okay? Now, I told them a paper has 4 different sections: an introduction, a methods, a results, a discussion. The introduction says, what's the question and why? Methods, what did you do? Results, what was the observation? And the discussion is, who cares?
Okay, so now he's going through and talking about the important parts of writing a scientific paper. Is that telling a story, thumbs up, or is that high five, teaching us facts about what we should do? Ready? 1, 2, 3, go. Very good, right? He's teaching us those facts about what you need in a science paper. I'm going to skip forward a little bit to get closer to the end so we have time for the assignment, okay?
What was the feedback like? Well, it was published 2 days before Christmas, downloaded 30,000 times in the first day, right? It was Editor's Choice in Science, which is a top science magazine. It's forever freely accessible by biology lists. It's the only paper that will ever be freely accessible by this journal. Last year, it was the second most downloaded paper by Biology Letters, and the feedback from not just scientists and teachers, but the public as well. And I'll just read one. I have read Black Mountain Bees recently. I don't have words to explain exactly how I'm feeling right now. What you guys have done is real, true, and amazing. Curiosity, interest, innocence, and zeal are the most basic, most important things to do science. Who else can have these qualities more than children? Please congratulate your children's team from my side. So, I'd like to conclude with a physical metaphor. Can I do it on you? Okay, yeah, come on. Yeah, okay. Now, science is about taking risks, so this is a incredible risk, right? For me, not for him, right? Because we've only done this once before. And you like technology, right? Yes. All right, so this is the epitome of technology. Mm-hmm. Right, okay, now. Okay. Now, we're going to do a little demonstration, right? You have to close your eyes, and you have to point where you hear me clapping, all right? Okay, how about if everyone over there shouts, 1, 2, 3? Brilliant. Now open your eyes. We'll do it one more time. Everyone over there shout. Where's the sound coming from? Thank you very much.
All right, so we're going to stop that part there. All right, we're going to come back to our flip chart here. Whoa. All right, and let's talk about really quick, how do you think this was made? What do you think they did to make this TED Talk? Corbin, go ahead.
So, TED Talk, they were talking about science stuff, and that, like, bees, and then he went on to sound, and then at first he was talking about what do you see, and say it.
Okay, so they definitely put multiple parts together, right?
There's only 3 different categories.
Yeah, so he definitely had to stop, think, and kind of do these different parts and pieces, like when he made it. Then they recorded it all together, right? So what were those parts and how do they go together? So let's think about it. Part of what he did was explain what they did in a story, right, as scientists. So part of it was explaining to you what they did and telling that story. And then the other part was doing what? So he explained the experiment. He told that like a story. First we did this, then the students did this, then they went off and we learned this and published a paper, right? Did you, if he didn't take time to explain it, would you have understood what was in the paper and what it meant? If he didn't take time to explain it, would you have understood what that science paper was?
No.
No, right? If he didn't take time to teach you some facts, we wouldn't have understood it as well. So he combined, here's what we did, here's a story, with expository information that included facts, right? That's what a hybrid text is. This is just him talking through it. So a lot of times, I'm going to grab a book really quick. Like this one about the American Revolution, about King George. It tells the story and the different things King George had to do, but it also stops and puts in expository parts and teaches you what that information is so you understand it. All right? So your assignment today, and we're going to watch another TED Talk. We're going to watch it together before you submit your assignment, is you're going to go to reading. Okay, so you're going to go down to Wednesday, and you're going to go to reading. And then we're going to watch we have a TED Talks assignment. You're going to watch another TED Talk. We're going to play it together here. And then it says, after watching the TED Talk, same questions we just talked about. How do you think it was made? And what are the parts of the TED Talk and how do they go together? Kind of just what we talked about, right? There's parts where they told a story, and then there were parts where they taught scientific information to help you understand the story. They go together because the scientific information helps you understand the story. So I'm going to go ahead and play this, and we're going to watch through as much as we can before I send you off to do the assignment alone, okay?
Started, I have a quick question for the audience. By any chance, did anyone happen to bring with them this morning a calculator? Seriously, if you have a calculator with you, raise your hand. Raise your hand. Was your hand go up? Now bring it out. Bring it out. Anybody else? I see one way in the back. You, sir. That's 3. And anybody on this side here? Okay, you over there on the aisle. Would the 4 of you with calculators please bring out your calculators, then join me up on stage, and let's give these volunteers a nice round of applause. That's right. Now, since I haven't had the chance to work with these calculators, I need to make sure that they are all working properly. Would somebody get us started by giving us a 2-digit number, please? How about a 2-digit number? 22. And another 2-digit number, sir. 47. Multiply 22 times 47. Make sure you get 1,034, or the calculators are not working. Do all of you get 1,034? 1,034? No. 594. Let's give 3 of them a nice round of applause there. Would you like to try a more standard calculator just in case? Okay, great. What I'm going to try and do then, I noticed that took some of you a little bit of time to get your answer. That's okay. I'll give you a shortcut for multiplying even faster on the calculator. There's something called the square of a number, which most of you know is taking a number and multiplying it by itself. For instance, 5 squared would be 25. Now, the way we can square on most calculators, let me demonstrate with this one, is by taking the numbers such as 5, hitting times, and then equals. And on most calculators, that will give you the square. On some of these ancient RPN calculators, you've got an x squared button on it, will allow you to do the calculation even faster. What I'm going to try and do now is to square in my head 4 two-digit numbers faster than they can do on their calculators, even using the shortcut method. What I'll use is the second row this time. I get 4 of you, 1, 2, 3, 4, to each yell out a two-digit number, and if you would square the first number, and if you would square the second, the third, and the fourth, I will try and race you to the answer. Okay, so quickly, a two-digit number, please. 37 squared, okay. 23 squared, okay. 59 squared, okay. And finally, 93 squared. Would you call out your answers, please? 1369, 529, 3481. Thank you very much.
Okay, so do you guys notice how he's going back and forth, just like we talked about with the text? Part of the time he's doing the magic trick, right, which is the narrative piece. It's almost like telling a story where he's doing the math magic trick. And the other part of it, he's explaining the trick, or he's explaining like the square root. So the expository piece of the text is him explaining the mathematics, and the narrative part is him doing the actual trick, right? We're going to watch about 5 more minutes together, and then I'm going to let you go work on the assignment alone while we're on here, okay?
Let me try to take this one step further. I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone I point to call out a 3-digit number. Anyone on our panel verify the answer. Just give some indication if it's right. A 3-digit number, sir, yes? 987. 987 squared is 974,169. Yes? Good. Another 3-digit. Another 3-digit number, sir. 457 squared is 205,849. 205849. Yes? Okay, another 3-digit number, sir. 321 is 103,041. 103041. Yes? One more 3-digit number, please. 722 is 500. Ooh, that's a harder one. Is that 513,284? Yes. One more 3-digit number, please. 162 squared is 26,244. Thank you very much. Let me try to take this one step further. I'm going to try to square a 4-digit number this time. Now, you can all take your time on this. I will not beat you to the answer on this one, but I will try to get the answer right. To make this a little bit more random, let's take the 4th row this time. Let's say 1, 2, 3, 4. If each of you would call out a single digit between 0 and 9, that will be the 4-digit number that I'll square. 9, 7, 5, 8. 9758. This will take me a little bit of time, so bear with me. 95 million 218,564. Yes. Thank you very much. Now, I would attempt to square a 5-digit number, and I can, but unfortunately, most calculators cannot. 8-digit capacity, don't you hate that? So since we've reached the limits of our calculators, what's that? Does yours go? Does yours go higher?
How many numbers is that?
Yours does? I'll talk to you later. In the meanwhile, let me conclude the first part of my show by doing something a little trickier. Let's take the largest number on the board here, 8649. Would you each enter that on your calculator? And instead of squaring it this time, I want you to take that number and multiply it by any 3-digit number that you want. But don't tell me what you're multiplying by. Just multiply it by any random 3-digit number. So you should have as an answer either a 6-digit or probably a 7-digit number. How many digits do you have, 6 or 7? 7, and yours? 7?
Okay, so I'm going to stop it there, and I'm going to give you time now to go and respond to this question, all right? So you're going to log on to Canvas, go to reading, and then discussion, and the question says, how do you think the TED Talk was made? So first of all, what did he have to do to make it? So you might say something like, number one, I think to make the TED Talk, he had to practice and memorize ways to solve math problems quickly in his head. He needed to be able to explain how to solve these problems, right? Then he used those strategies and explained and recorded them for the audience, right? So that'd be like a good thing for number one. Then number two says, what are the parts of the TED Talk? And that's what we're going to talk about. Part of it is him doing the magic tricks, right? That's an example of what kind. Don't tell me now. You're going to put that in your answer. The other part of it is him actually explaining the math behind it. And that would be expository. How do we know that? Okay. So you have about 12 minutes that I'm going to give you to go on and start this. If you're not done, when I send you to the waiting room, you can finish it. All right. If you have any questions or you need help, just unmute yourself and ask. Okay. I'm going to mute myself for now, but if a question comes up, unmute yourself and ask me, and I'm willing to help you. Okay.